and welcome to Hadoop exam learning resources. In this session we are going to cover Apache Flume, and this is the introduction of Apache Flume. In future session we will cover in depth about each component of Apache Flume. So we will suggest you subscribe to this channel so you can view and you can get the information whenever new module is added about Apache Flume. So in this session we are going to cover the data acquisition for the Hadoop framework using the Flume, and then later on we will see the each components of the Apache Flume. Then we see the difference between POSIX based and HDFS based file system, how HDFS differ from POSIX file system. Then next we will cover the Flume events. This is the very important component of any Flume data transfer from one server to HDFS file system. And next we will see the various components of the Apache Flume. That would be just an introduction for the each component, where and how does it fit in the Hadoop with the Flume. So let's start with our session of Hadoop framework. Okay, so our first topic is data acquisition. What we mean here, data acquisition. So you know the Hadoop framework, this is your Hadoop framework, can process huge volume of data. Like there are thousands of nodes of Hadoop. Okay, and this is, you can say, your name node or job tracker, and these are the data node. So this is based on the HDFS file system. So you know this Hadoop framework can process huge volume of data, but how this data would be transferred to the HDFS file system? So let's assume there are e-commerce websites like eBay, Amazon or something which are running various application servers. This app servers continuously producing a huge volume of logs, like which users buy any product or something. Now let's another website like Facebook, Twitter. There are also various application servers are running, which is also producing huge volume of data which needs to be processed by the Hadoop framework. Let's another example is stock market. Tick by tick data is being produced by stock market, and this also stored into the some of the log file or system logs or whatever you can say. This is some files where this will be stored. And then there are cloud infrastructure where a lot of servers are already installed, like in the cloud, like Amazon Web Service Cloud, you can say example. There are a lot of servers are running and they are producing a lot of files. Now this file needs to be processed by the HDFS file system. How do you put this file into the HDFS file system? That is the question. So using the command, you can directly push one file at a time to the HDFS file system. That is possible, one file at a time. But now question is, my data generation is so fast, it is continuously producing this data, each server. Stock market tick by tick data, every moment data is being generated. My server logs, like as person visits the websites, the logs is generated. So huge volume of logs is generated, and this is continuously generated, and we want to continuously analyze this data. So how to push this data into the HDFS file system? So we need something in between which is responsible to continuously transfer this data as soon as it is placed from to the HDFS. So the component which does this task, that is called Flume. So Apache Flume is the component which is created, which continuously whenever the data is generated would be passed to the HDFS file system. So this is the use of the Apache Flume. Okay, so and Apache Flume has various components which, like we can say, like source, we'll go in detail about this. Like the next is like sinks, channels. There are various kind of channels in the Flume. We'll discuss what this each component mean, but just let me write down the name so you can just remember. There are various component: interceptors, channel selectors, agent, sync processor, and eighth is Flume event. You need to understand this each of the component of the Flume to understand Flume in detail, how it is being used. So we'll go one by one on each component. So let me first again go to the some introductory part about the Flume. So then we will move to the individual components. So these are there are various websites, application servers, web server creating the data all the times, as I have shown in the picture. So we need continuously this data to be uploaded to HDFS file system. One time load is easily can be done using the command HDFS command. So from one file system to another file system. So let's first compare why HDF like compare POSIX based file system and HDFS file system, how it different. So like not all the things we will discuss about their difference, but small things which is very important for in context of the Flume we'll discuss here. So why HDFS lead Flume and POSIX based systems are generally can be easily handle the streaming of the data or something. So let's discuss point by point first. On we will discuss on the POSIX first. So POSIX file system, if you open, suppose this is your computer, let's say any Windows machine or any operating system you are working upon. Okay, so now you are a client. A client, any other tool also can be a client, or user can be a client who wants to write a file to this Windows box machine. He can write this file. So while writing the file, if what it exactly does, it open a file, create a file inside this and stream the data here, the data on this box. Between like suppose 60% file is written and this network goes or some error happens, then what happens? Then in this case the file which is already written on this file system would remain on this file system and other would not be written. So the file which is already been written on this file system can be read. It's not necessary you can read it or something, it might corrupt it or something, you cannot open it, but some whatever you have written is still there and you might use it, you might not use it, it depends on the OS to OS, but in the POSIX based file system it is possible. So whatever written on the disk will remain on the disk. But in case of the HDFS, what happens? Okay, so this is the very important thing here. In case of HDFS, suppose you are writing in the HDFS one of the file, it is just like container of the block. So you know the file is divided into the blocks and each block is written to the disk. So if replication factor is enabled, then first block is written to the first node and from there it goes to the another node. So this will be transferred using this like pipeline concept, we can say, like block is written. But whenever like situation happens, if network goes here in HDFS case, so a Hadoop framework will not keep the half written data over here. Whatever is written on the disk would be would not be used, like it won't be there, it would be just an empty directory. The data would be lost if the network, if the file is not completely written, like 60% file is written and then network goes, then whatever written onto the this disk would goes. So here the no data could be available if network goes. So that is the difference between HDFS file system and the POSIX based file system. So that is why it needs a different way of handling the or pushing the data into the HDFS file system, because this is not as your traditional file system. This is very specially written for the distributed computing. So this has completely different behavior. HDFS file system, you cannot easily mount the drive or here, like which you can do here. So that's why you need Apache Flume to transfer, to stream the data to the HDFS file system. So that is the main difference between POSIX based and HDFS file system. Now next move to the like components which we were discussing about the Apache Flume. Okay, so the let me draw the diagram. Suppose this is your application servers, app servers, which is producing the data. Now here is the, I just say this is the your the so generation, data generation part. Now this is the world of, like not world of, like I would say this is source part. This is now, this is I would say the data generation area, and this is Apache Flume area. Okay, I'll divide in three part, and this is your HDFS area where the Hadoop lies. So now the data which is generated over here will be first passed to the source. Okay, so this source is part of the Apache Flume. So this is input for the Apache Flume. Then the part which write sync, this sync writes data to HDFS. It could also write to HBase database as well. Okay, so because the HDFS based HBase is there, so it supports like writing to HBase as well. So this is sync, this is the input part, this is your output, you can say, and there is a glue in between which works as a glue, that is called channel. This is the channel which works in between source and sync. Okay, and all these three component is run inside a daemon process which is called agent. So now agent is responsible for running all this processes inside this. Just like this source, this is sync, and this channel. Okay, so this area is agent, and there are other component as well, we'll discuss. So now the basic data, which is, this is the data, right? Now this data is transferred from source. So now this data is called, each data point is called event which is transferred. So you can say Flume event. These are the various events where actual payload, this actual data is contained in this. Suppose, give you an example. This is your log file. This log file contains like timestamp and your actual message inside this. So now my Flume event could be like, look like this, is divided into two parts. First is header and second is payload. Okay, so the actual message here, and this is the header. Okay, this header is there, and this represents your Flume event. So this Flume event travels from source to the sink you inside the agent. Okay, so there could be not necessarily always header is there could be zero headers or more than one headers as well. Headers are key stored as a key value pair. Suppose you want to send your event with the informations like what is the time when the event is generated, so you can say this is the time and value when the event is generated. That would be your header part. at what at what host it has been generated, so server IP or something you can put in the header information. This information is used by the sync or interceptors or many routing mechanisms for the many routing mechanism. Okay, so this is the how your Flume event looks like. So and this the payload part is just an byte array. Okay, it is an array of bytes that contain the actual payload, actual data information inside this. So this is the Flume event. So here one more important point, it not necessarily you could have single channel, you could have multiple channel as well over here. So source could write data to event, you can say event to one channel or more than one channel based on your how you configured it depends on that. So channel can write it. A channel is holding area, so this channel is called, okay, so I have lack of space, I will use this space here. Okay, so channel you can say is an holding area where events are stored for before it is being passed to the sink, from source to a sink. And sink process the events only through the channel. It cannot directly take the event from the source, it has come from the channel only. Sink can process the events only from the channel. And a agent, okay, so this agent could have, let me clean it out, agent can have multiple channels, similarly multiple source, multiple sinks, etc. So this is how the agent and all the components look like into the whole overall diagram when data transfer from source to the sink and actual data where it is generated. Okay, so now next components which are also used in the Apache Flume, that is interceptors, channel selectors. So now you understand this channels and etc, so you can understand this more advanced concept or component of this Apache Flume. So we'll discuss one by one their introductory. So first is interceptors. Using the interceptors you can alter your Flume events or inspect this event. So whatever events, suppose this is the source and this is channel, and between this you could have interceptors as it name suggests, interceptors. Okay, so whatever event needs to be sent to channel can be inspected by this or can be filtered, like you don't want some of the events like to be passed, like I would say like my Apache logging, I'm there, so there's a info log, there is a warning log, there is a trace log just. So trace is not useful for me, so I can filter it out from here only, and would not be passed further to the channel, so which we can avoid unnecessary logging to pass to the channel and to be stored into the HDFS. So this can be done into the interceptor. An interceptor could be always be between source and channel, or channel and sink. Sink can also have in between interceptors. Okay, so and suppose this is my source, this is my channel, source and channel. So, and it is not necessarily there would be only single interceptor, there could be multiple interceptors. I would just give name I1, I2 or something, I3. So there are three interceptors. So in Flume event which is generated from source to channel would be passed to three interceptors one by one, and where each interceptor would have some logic inside this to filter it out, or enrichment of the events, or any header information can be useful. So from this perspective, this interceptors are used. Now next is a channel selectors. So as name suggests, channel selector is in which channel the data should, my flow event should go. So as you know, we have already told like source, and it could have send event to multiple channels. Suppose channel 1, channel 2 and channel 3. Why we need multiple channels we will discuss in the future session, but for this purpose, like my Flume event is generated should be like, I would say Flume event needs to be on which channel it should go, either all the channels or particular channels. It's possible. So there is a component in between that is called channel selectors. This Flume event goes to channel selector, and channel selector decides in which channel this event should go. It should go only in channel 1, not in channel 2 and channel 3. So this kind of this decision can be taken by the channel selectors. But there are also various kind of channel selectors. So like first one is default channel selector. If you don't configure any channel selector, so then it would be default one, that is called replicating channel selector. The purpose of this channel selector is simply puts a copy of the event into each channel, assuming you have configured more than one. So it simply replicate all events, like there are three channels. So this event, your event, Flume event would be copied to each channel. That is the replicating channel selector, which is by default does this task. So this is your source, and these are channel 1, channel 2, channel 3. Okay, and this is event, and between channel selectors which transfer the event to the each channel. That is called replicating channel selector. Next channel selector is multiplexing channel selector. This multiplexing channel selector is used, which can write to different channel depending on certain header information. So as I told you previously, like this is my source, and this generates one Flume event which also has one header information. Okay, this is my payload. So based on this, I would guess just selectors. based on this header information, so like on which channel this data should be based off. So there could be each channel is now putting data into the different Hadoop cluster. It's not directly to the channel, it could be like in between sync, and this put into the different Hadoop cluster or something, or it would write into the HBase. So based on the header information, what is the origin, where this event is being has been originated, like on which data center or on which application server or something, based on this multiplexing selectors which has been configured will decide on which channel this event should be transferred, and from there to sync and then sync to the HDFS file system. Hence intercept logic and selectors. So in between you could also have interceptors as well, correct? So this is interceptors, this is selectors. So this combined will define routing for the your individual Flume event. So that is the importance of this individual component. So now next is the last component which we are going to discuss is sync processor. Sync processor is the mechanism by which you can create failover paths. So you can configure failover. How we can do, we will discuss in the future session, but you can do failover using the sync processor. You can do the load balancing whenever the events are lot of events, so you can configure the load balance. So it could be like multiple syncs are there, so on which sync your event should be gone, based on load balancing can be done using the sync processor. So that's all about Apache Flume. I hope you have enjoyed this Apache Hadoop learning or Apache Flume training. So let me give the brief introduction about Hadoop exam learning resources. So you just have to visit hadoopexam.com. Okay, so this is hadoopexam.com website where we have various product from the Hadoop exams: Cloudera developer certification, Cloudera administration certification, Hadoop training in detail, Cloudera HBase certification, Amazon web service certification. So you can see here about us by clicking over here in detail, like we are providing 6 products right now, so you can visit. So for more detail you visit this websites, and thanks for listening. I hope you have enjoyed, and I suggest please don't forget to subscribe about this channel so you can get future update from this video.